Hi everybody, it's Miss Freeman here, ready for some notes! Today we're going to factor out the greatest common factor. Our first example will be to write the prime factorization of 4, 8, and 3, 6 and find the greatest common factor. So I want you to go back to those lovely factor trees that you learned in middle school. So we're going to take 48 and find the prime factors. And you might have learned a different method, but I like to use the little factor tree. So if it's an even number, like 48 is, I'm going to divide by 2. So 48 divided by 2 is 2 and 24. Then 24, 2 and 12, 12, 2 and 6, 6 is 2 and 3. So I can't break that any further down to its prime factors. So that's where I stop. So then to find the prime factorization of 48, that would be 2 4 times. So there's 1, 2, 3, 4 2s. So that's 2 to the 4th. And then you have a 3. So the prime factorization of 48 is 2 to the 4th times 3. So now what I want you to do is do the prime factorization of 36 by yourself. Okay, so there's the factor tree for 36. So its prime factorization is 2 squared times 3 squared. So now my goal here is to find the GCF of 48 and 36. And like I said at the beginning, there are different ways of finding it. But this is the way that I want to show you for this lesson. So what I have in common is I have 4 2's over here and 2 2's over here. So what they have in common would be 2 of those 2's. So they have 2 squared in common. And then they have 1 3 and then 2 3's. So they only have 1 3 in common. So that's the GCF. And then 2 squared is 4. 4 times 3 is 12. Now, I went through that really quickly because that is review. You should have known that coming into this class. So if you need more help with finding the GCF, that's something you need to come see me or go to the math lab for. Okay, now we're going to find the GCF, but now we're going to apply algebra. So we're going to look at variables and exponents. So just like with example 1, I was finding what was in common. So you're going to do the same thing here for example 2. Find the GCF. For part A, we have a bunch of variables and exponents here. So if we start looking at just the x's, so in the first one I have x to the 4th, and the second one I have x squared. So what they have in common would be 2 x's. So the x's would be x squared. Then if I move to the y's, in the first one I have y squared, the second one is y cubed. So what I have in common would be y squared. And then finally the z. I have 1 z over here and 4 z's over here, so I only have 1 z in common. So the GCF, the greatest common factor of these two expressions, is x squared y squared times z. Okay, so for my second example, now I have coefficients in front. So the coefficients 8 and 12, we're going to just find the GCF of 8 and 12. So if you think about that, you can think about it in your head, or you can think about the prime factorizations. This one's a really easy one. The GCF of 8 and 12 is just 4. And then if you look at the x's, you have 5 here and 7 here. So the GCF would be x to the 5th. And then you have y to the 6th and y squared, so your GCF would be y squared. So 4x to the 5th y squared is my GCF of those two expressions. Okay, so we're going to look at this factoring in a little bit different way. So for example 3, I'm going to give you some missing equations. So I want you to find the missing factor of these equations. So the first one, I'm going to start off easy just to show you what I'm talking about. If you have 15, then 15 is equal to 3 times what? So what I mean by that is find the missing factor. Okay, and obviously I think everybody would be able to say 5. And so just to remind you that 3 and 5 are called factors of 15. Another way of thinking of that is the way you would find that is to find that missing factor, then you would be dividing 15 by 5. And 15 divided by, we were dividing by 3. Dividing by 3, and then we got our missing factor of 5. Okay, so what we're going to be looking at is now, instead of just numbers and dividing those numbers and finding factors, we're going to be finding factors of numbers and variables together. Okay, so the second one that we're going to find the missing factor of is this one. Okay, so 18c to the 9th equals negative 6c to the 4th times what? All right, so the first one was easy. 15 equals 30 times 5. So you divide 15 by 3. So the second one, it might be a little bit harder for some people to see. So I want you to use that same method in A of thinking of dividing that 18c to the ninth by its first factor that we know is negative 6c to the fourth. And so now this expression that you have right here, this is exactly what we had on the previous unit, what we were learning with the exponent rules. Okay, so this is would be like a division problem. So then you subtract the exponents. So the division are the big numbers, 18 and negative 6. You just simply divide that. So 18 divided by negative 6 would be negative 3. And then the c's, those have exponents. So since I'm dividing the c's, you subtract the exponents. So that would be 9 minus 4, which would be an exponent of 5. Okay. So I factored 18c to the ninth by having the one factor, negative 6c to the fourth, finding its other factor, negative 3c to the fifth. Now, you could always double check your work just to see. So if you wanted to check your work, then you could just multiply back through. So negative 6 times negative 3 is positive 18. C to the fourth times c to the fifth, those are multiplying, so you add their exponents and you get 18c to the ninth. Okay, so you can always check your work. Okay, so let's try another one. 16x to the fourth y cubed equals 8x squared y times what? Some of you can do this automatically in your head, but if you need to, you can show that you're dividing that 16 by 8x squared y. So then divide, 16 divided by 8 is 2. Then x to the fourth over x squared, subtract, and you get x squared. And then y cubed over y to the first, you'll get y squared as well. And that's my answer. Okay, so now for just a couple of notes that I want to make sure you have. So I'm going to star this because this is important. What I want you to remember is when we were multiplying polynomials, we would do what's called distribution. So we would distribute to multiply polynomials. Okay, that's the unit that we just came out of. We were multiplying polynomials. We learned how to double distribute and things like that. So just as an example really quickly, a very, very simple example, if I were to distribute 2 times a plus b, then that 2 would go to both the a and the b, and you would say my answer would be 2a plus 2b. Okay, so that's called multiplying polynomials, and we would distribute to do that. Now, remember when you were a little kid and you first were learning how to add, subtract, then you learned how to multiply, then you learned how to divide. So naturally, we just learned how to multiply, add, and subtract polynomials. So guess what we're doing in this unit is we are now dividing polynomials. Now we don't say the word divide polynomials, we actually use the word factor polynomials. So you can kind of think that factoring is like dividing a little bit because that is what a factor is. It's how a number is divided. So we're going to factor to kind of undistribute. Undistribute. So it's like the opposite of distributing. We're going to undo that distributing. And that's what we're going to do in this unit, is we're going to basically undistribute polynomials. Okay? So in the first lesson, or the last unit, I gave you 2 times parentheses a plus b. So now what's happening in this whole unit is I'm giving you, very basic of course, if I gave you 2a plus 2b, that's what I give you, and I ask you to factor that. So what that means is you want to take out what is in common. You want to find the GCF. And that's really what factor means for right now, is we're going to find the GCF to take out of the polynomial. All right, so I've just given you, obviously, the answer that I got when I multiplied those polynomials, 2a plus 2b. So now if I were to take out what's in common, the GCF here is 2. So you would take that out. So what I mean by take that out is you would write that GCF first. And then in parentheses, you would write what was left over. So I have an a and then a b. So when I take that 2 out, you get a plus b. So it's really undoing that multiplication or distribution. Okay, so now we're gotten to the actual meat of the lesson, the main part of the lesson. So we want to factor out the GCF. So what we want to find is the GCF of the two terms and then take that out, undistribute it from this polynomial. So we want to look at these two terms and find the GCF. So just like we did a couple of problems ago, we were just finding GCF. So here we have 3 and 6, and what's in common with 3 and 6 is 3. Then you have the m cubed and m squared. So the GCF there would be m squared. Okay, so the GCF is 3m squared. Now you cannot stop there because my final answer, what it's going to look like is you're going to have parentheses in your answer. So you're taking out that GCF and then you have to figure out, okay, what was left over inside of that polynomial. So 3m squared is like what's sitting in front of my parentheses. And so to figure out what's going inside those parentheses, you have to divide. Now, if it helps you off to the side, my first term was 3m cubed. That was the first thing. So if I'm dividing, I'm taking out 3m squared, then off to the side, if you need to, you can say, okay, I'm going to divide that by my GCF, 3m squared. So using our exponent rules that we learned, 3 divided by 3 is just 1, and then m cubed over m squared, you're just left with 1m. Okay, so that's what's going to go right here is the first m. So this first term right here, when I factored out 3m squared, I'm left with a single m. So then you can kind of think now, if that was being multiplied back through, 3m squared times m would be 3m cubed. Okay, so now for the other factor. So the other factor was 6m squared. That was my second thing here. And so if I divide by that GCF, 3m squared, you do the same thing. 6 divided by 3 is 2. M squared over m squared goes to 1. So I'm just left with plus 2. All right, so this is what it looks like. If I were to ask you to factor, this is what the final answer would look like. Something out in front of parentheses, and then something else inside those parentheses. Now again, you can check your work. If you want to check your work, then you can just simply redistribute back in, and you would get 3m cubed plus 6m squared, and see if that's what you started with, and it is. Okay? So let's try one more example like that. Okay, so now I have 4a squared minus 10a. So I want to factor this, so the first thing I want to do is find the GCF. So I'm looking at 4a squared and negative 10a. So 4 and 10, the GCF there would be 2, and then a squared and a, the GCF would be a. So that's going to be what comes out in front of those parentheses. Then if I divide, if you divide 4a squared by 2a, then you would get 2a, right? Because 2a times 2a would be 4a squared. Then if you wanted to divide 10a by 2a, then you would get just 5. And that would be a minus 5. Okay, so that's my answer. Again, if you wanted to check, you could get back to the same original answer. Okay, we're just going to do 2 more problems. My last example, I want you to see that we're going to factor out a negative if the first term is negative. Okay, so in the previous example 4, part B, you saw I had a negative here, but I didn't factor out a negative. That's because the 4, the front, did not have a negative. But now, if you have a negative as your first thing, then you need to factor out that negative. Now, that's, of course, given that your polynomial is in standard form. So if your polynomial is in standard form and the first thing is a negative, you want to factor out a negative. So let's get an example with that. So as you can see, first of all, this is in standard form because my exponents go in descending order. All right, so now I need to find the GCF. And since my first thing is negative, my GCF needs to be negative. I need to factor out a negative. So then with 3 and 12, the greatest common factor is 3. And then m to the 5th and m cubed, you have m cubed. So I'm going to factor out a negative 3m cubed. And so when you take that out, you divide and see what you have left. So off to the side, my first term was negative 3m to the fifth divided by negative 3m cubed. And that would be just m squared, because the negatives cancel, the 3's cancel. So m squared sits here. And then my second term, don't forget, it takes the negative in front of it. So you have negative 12m cubed divided by, my GCF was negative 3m cubed. So that would be, negatives cancel, 4m cubes cancel. So I'm just left with positive 4. Not a negative anymore because that negative was factored out. Okay, and again, you can check your answer by multiplying through. All right, so we just have one final example that we're going to do. So like I said, in order to factor out that negative, so right now you don't see a negative at the beginning, but you have to make sure that before you factor, you are in standard form. And as you can see, we're not, because this exponent's 2 and then 3. So we need to rewrite in standard form. And that negative right there goes with the 21. All right, so that's going to rewrite to be negative 21x cubed plus 7x squared. So now when I rewrite in standard, I do have a negative in front. So when I factor out that GCF, I am going to have to factor out the negative. So that's going to be a negative 21 and 7. GCF is 7. And then x squared. So that's going to what's come out of my parentheses. And then you can come over to the side and divide to find out what goes inside the parentheses. So negative divided by negative is positive 3. X cubed divided by x squared is x. So the first thing is 3x. Then my second term is 7x squared. And it's a positive 7x squared divided by a negative 7x squared. So actually, everything cancels out. The 7's cancels, the x squareds cancel. If everything cancels, you're not left with 0. Make sure you get that. You're not left with 0. You're actually left with 1. And since that there's a negative sitting here in the bottom, it's actually a negative 1. That's huge right there. That's very, very, very important. Okay? So you're left with a minus 1. You have to have something there in order to multiply. If you leave it as 0, then it would be incorrect. So this is my final factored answer. All right, so that's our first lesson on how to factor.